Hey guys, my name is Joanne and I'm going to talk about the difference between chiral versus achiral molecules. This is something that gave me a little bit of trouble before, so I just wanted to clarify a few points. The first steps to do to tell if it's achiral, definitely use Marvin Sketch. I provided the download link in case you guys don't have it, and some of the examples that I'll be showing they're on the Marvin Sketch applet, so it'll show you guys how to use it. So basically what you're looking for achiral is a superimposable mirror image. So how to do that is you're going to draw that molecule Marvin Sketch, copy and paste the drawing and have a mirror image, but you want to keep the wedges and dashes the same and see if the molecule is superimposable. So basically the idea is for achiral, you want a superimposable mirror image. For example, if you have a tetrahedral structure like it was shown in the lecture video, if you have two of the bonds that are the same, the lecture video showed two hydrogens, but in other examples, if you have two chlorine bonds, that does not make it a chiral molecule, so it's achiral. Another thing that you want to look out for is symmetry. I'll have an example of that soon. So to tell if it's chiral, again, draw it out in Marvin's sketch. Look for a non-superimposable mirror image this time. Another thing I want to know is if you have a carbon with the chiral center, that means that carbon is bonded to 4 different groups, not necessarily 4 different atoms, but 4 different groups, and again we'll go into an example of that. But if you do not have a molecule that has any chiral centers, usually that indicates that the molecule is not chiral. And again we'll go into an example. And if you still need help, what I referenced was the Khan Academy. They have beautiful lectures regarding the chiral versus achiral. So we're going to go into the examples. So you have a tetrahedral structure. So like we mentioned in lecture, this is a chiral center because it's bonded to 4 different groups. So this molecule is going to be chiral, but to check by a mirror image, what you want to do is highlight it, edit, copy, edit, paste. You're going to bring it over here. What I'm trying to do is make it into a mirror image. So you're going to highlight it again, edit, transformation, flip horizontally. You see that the bonds, they have to be kept the same, so this still has to be wedged. Now it's a mirror image. Now if I were to rotate this in any way, it still would not equal this image. So if I were to rotate this fluorine to move it over here to make it look like this methyl group is going to take the place of this hydrogen. So still it's not going to be superimposable. You cannot put this on top of the other, showing that this is a chiral molecule. The second example I have, I wanted to talk about chiral centers. So any of these carbons over here, they're not going to be chiral centers because they have 2 hydrogen molecules. And for a chiral center to be a chiral center, you need to have 4 different groups. This is still not a chiral center, even though you have a bromine and a hydrogen. If you look from the left, you have 1, 2, 3, 4, 5 carbon groups before you get to this specific carbon. And if you look from the right, you have 1, 2, 3, 4, 5 different carbon groups before you get to the carbon that we're looking at. So basically these groups are pretty much the same from the left and the right, so you still do not have a chiral center here. And this molecule is it's going to be achiral because if we're considering symmetry, if we were to just break it down, if we were to just draw a line of symmetry this way, it would still be even, and we're not going to take into account this because it's going to be in the plane. So this is going to be considered an achiral molecule. So I hope that helped. If you still need additional assistance, I highly recommend looking into the Khan Academy lectures. Thank you so much.